4, Rope Physics Spring Mass Lab. In this lab, we will examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. We will find that we can understand and predict this motion using Newton's second law as well as the energy principle. The predicted motion of the mass followed the same pattern as the data received from tracker. The spring mass system satisfies the energy principle. So first what I will do is show the system in tracker. So each point is plotted here on the graph. We have one graph that shows the time in X and the other graph that shows the time in Y. So some principles that we will use. We'll use Newton's second law to predict a new velocity and a new position. We also use the energy principle, which is defined as the change in energy equals the change in kinetic energy plus the change in potential energy from the spring and the change in potential energy from gravity. The change in energy is equal to 0 in this case because nothing is acting on the system. The change in kinetic energy is equal to 1/2 times mass times velocity squared. The change in potential energy due to the spring equals 1/2 times spring stiffness times s squared. And the changing potential energy due to gravity is equal to mass times gravity times height. So some initial conditions. The mass of the object is 0.420 kilograms. The initial position is negative 0.11 and negative 0.62 meters. The initial velocity is 0 meters per second. The time taken for the object to complete a period is 1.54 seconds. The spring stiffness, which is calculated as K equals mass over T squared times 4 pi R squared times 4 pi squared equals 6.83 newtons over meter. The relaxed length is 0.123 meters. So we put this into Python and we get a computation model that resembles this. The red ball shows our observed motion and the blue ball shows the predicted motion using Python. We also graph the total energies using Python, and the blue line represents the change in kinetic energy. The red line shows the change in potential energy due to the spring, and the green line shows the potential energy due to gravity, and the yellow line shows the total changes in energy. And as you can see by the graph, the total changes of energy equals 0. Here, this graph shows the predicted versus the observed motion. The blue line shows the predicted motion, and the red line shows the observed motion. So some potential errors. Some potential errors of this this lab is the potential the way I tracked the data in tracker. Another error is the assumption that nothing is acting on the system. So what does it mean? First question was, for your model system, is the energy principle satisfied? Yes, it does. The energy principle states that the change in energy equals the change of kinetic energy plus the change of potential energy due to the spring plus the change in potential energy due to the gravitational constant equals 0. The graph previously shown shows that the change in energy is equal to 0. The other question was to estimate the period of oscillation from the x position and estimate the period of oscillation from the y position. The period of the oscillation in the x direction is 1.64 seconds, and the period of the oscillation in the y direction is 1.875 seconds. The reason for this is that the y direction is based on the mass and the spring stiffness, and the x direction is based on the length and gravity. Thank you.